Can 43. Partition array for maximum sum. Given an integer array, partition the array into contiguous subarrays of length at most k, and after partitioning, each subarray has their values changed to become the maximum value of that subarray. Return the largest sum of the given array after partitioning. Test cases are generated so that the answer fits in a 32-bit integer. Okay, so now there will be a k limit as a limitation of the length of the partitioning array, and then each partition array will be transformed into, like, each element in the partitioning array will be transformed into the maximum value in that subarray, and we have to return the largest sum of the array after partitioning. Okay, so like you will have at most 3 times of the max value in the subarray. Okay, so we only care about the maximum value in the subarray and also the length of the subarray. So I have questions like, will k be 0, like, or if k is larger than the array length? Oh, it will not. Okay. So it will not be larger than the array length. It will be, okay, smaller or equal. And so okay, I will try to look at the last element of the array. We cannot sort the array because the order is important, since it wants to partition the array into contiguous subarrays, so the order cannot be cannot change, so we cannot sort it. And I think, okay, so if array I is selected as a group already, selected as a group, then the problem shrinks to 5. finding partitions in array in the rest of the array. So it will be array 0 to array I minus 1. So if array I is selected, then okay, it has a lot of things to do if we want to do it in one, like, yeah, we have to keep track of each maximum, each sum, like each maximum value of the group, and I'm thinking maybe some greedy approach maybe like can work, because like we want larger, like we want each group has larger values so that yeah, so it can maximize the sum. Like if we have a group and this is a group, then we will have 5 times 4 is 20, and 7 times what we will have, and 7 times 3 it's 21, so it's 41 now, and then we have 9 times 4, so it will be 36, and it will be, oh no, we can have like this. It's 9 times 4 and 9 times 2, so it can have 9 times 6, 54, and then we can have 7 times 4, it's 28, so it is it is 82 and then 1, so it's 83. if array I is selected, array at I is selected as a group, then okay, if like the brute force solution will be can test every like we can check every length of the subarray, like since like k is 3, then we can try from 1, 2, or 3, and then and see which has the maximum sum. Okay, so if then I think we need do we need the k inside as a parameter? And we also need the maximum value. Oh, it will be like three parameters. Like if array I is selected as a group, if the group dense is smaller than k, okay, no, so we can also or if array I like I minus 1 like array I and array I minus 1 are selected, then the problem becomes like this. Array finding the partitions in array at index 0 to index I minus 2. Okay, sounds like, and so if array I till this is 2, so if like the length is k, if till array I minus like if length k, if length of k are selected as a group are selected, the problem will become now we have to figure out like so like k, and this will be, this is I and I minus 1, I minus 2, so it will be I minus, it will be I minus k plus 1. Yeah. I minus, yeah. and this will be I minus k. So we will have these or and try to like also we have to keep track of the current maximum of the group. If array I is selected as a group, if the current maximum, like if the group, I would say group max is larger, is larger than array I, then sum will be sum of the group will be group max it will be group it will be some group max added out by group max. I think I will write it down here, like else we should look at like how many, like the length of the group. It's a bit, can we, I'm thinking okay, if it has k, yeah, I am thinking of separating the steps. So I first get like the index of partition, like which, like the partition group, I mean like the starting point and ending point for each group. Then after finding that, then I will loop through the array and see like each length of the group and each group's max value. Yeah, not sure if yeah, I'm not sure if we can maintain length of the group. Like, yeah, maybe. Like, for example, if array is selected as a group, then group length plus 1. So, like, but then, yeah, we don't know. Yeah, I think maybe I am not sure like how to. Yeah, we have to find or if we first sum up each of the group value, is it working? I don't think so. Yeah, because partitioning will relate to the max value in each group. Okay, I want to check the solution. Oh, it only needs one parameter. How? Oh, I think I get it. Like, it kind of, yeah, like for selecting, for like if array I is selected, then try to find the problem strings to this is correct, and it also tries to find the sum of the group. Like find the sum of the group. This, and the group is contains only array I, and also for this, like find this, the group is array I minus 1, and this as well. Yeah, so it will be like time complexity will be big O and multiplied by K, since each of the state, like each okay, I think this is no, it is not in multiplied by K. It will be like for each like for each problem, array 0 to array I, you have K options. So it's K multiplied by, like K with the power of N. Yeah, it's like a tree, like every state, and you have K options. So it's more like yeah, you have K options, and you can select K, at most K element in a group, and see which one which has the maximum sum. Also, yeah. So Okay, and let's define DFSI. Yeah, it is like a tree structure. As I said, for each sub-array, array 0 to array I, including, it is like you have k options for each sub-array. So it is like a tree, and so I will use that first search first, and I'll define the function as DFS. It will have so the I will be the parameter indicating the ending index of each subarray. So it will be the maximum sum the maximum sum with the maximum sum of partitioning the array 0 to array I. And that is array I plus 1. So for DFSI, it will be like try to find the maximum, like if array I is selected, so the problem will become DFS I minus 1 plus sum of group with sum of like maximum sum. I will say maximum sum is not the typical sum. So maximum sum of array I, and it will be another option will be DFS I minus 2 plus the maximum sum of array I minus 1 to array I. And yeah, we can change this to a representation, like the slicing representation to like I plus 1. And this can be array I till I plus 1. I think it's confusing. I will leave it like this. And yeah, till and this is a group. This is an option, and this is an option, and another option will be DFS. Like the last option will be DFS I minus k plus plus the maximum sum of array minus clay plus 1 till array I. Yeah. Yeah, like for each state they have k options to calculate, and it has n states. And it's kind of okay, that's leave the term complexity for later on. So okay, boundaries will be if I is like I should like I minus k plus 1 should be larger than 0, larger or equal than 0. So it should not be smaller than 0. If it's smaller than 0, and also I should not be like partitioning array for the last element. Is if it's smaller than 0, return return 0. If I is 1, if I is 1, return array 0, like array at 0. If I is 2, yeah, let's stay with this. And let's start with given n as the length of the array, and we'll implement the function dfs. And the boundaries will we'll first have this: if I is smaller than 0, return 0. And since it is an empty array, if I is smaller than 0, it will be an empty array. Then it will have the sum of it will be 0. And yeah, I'm thinking of if I is 0, then return itself. But yeah, we will see later. So if we are not at the boundary for DFS, we will return sorry, we will have we will return the maximum, like it will be DFSJ for J in the range of I. Oh, and I but started with K. Let's see if this will be I minus 1. Oh, the largest one will be I minus 1, and then I minus 2. This will be I minus K. Yeah. And this will be, yeah, we will deal with them, like if we have another like some like we will call array A, since or we will have group, then like group, and we will do the calculation later on, and we will have max sum for array J till J plus 1 till I plus 1. Yeah. And okay, and like the most stupid way will be return like the max of the group and multiply by the length of the group. And for this thing, like K should be I minus K should be at least 0, or it should not. Okay, let's see, if K is 3, then I is 3, or how about it works yeah, but if I is 2 and k is 3 now, then I think we will have max, oh, 0 here. Yeah, at this it should be 0. And if range 0 to I, if I is 0, then yeah, I think we will have, if I is 0, return itself. Okay. Then return DFS and -1. Yeah, since the definition of DFSI will be the maximum sum of the array 0 to array I, and array I is included, so yeah. Oh, this is correct. This is something went wrong here. Okay, not sure where it went wrong. Maybe we can try run this one. I'm not sure if, so for maximum, let's first check the index if it's correct. So j will be 0 to I minus 1 if we don't consider k, then yeah, like the largest j will be I, oh no, it's correct. So the largest j will be I minus 1, and yeah, this j has to be like if this is I minus k, it should be I minus k plus 1, correct, and this should be I plus 1, it's correct as well. Yeah, I don't think, okay, let's see. So for this one, it will be n is 7, and so it will be here at 6. So it started with 10. So 6, it's the maximum between, you will have a for loop from 6 minus k, 3 is 3. So for j in range 3 to 6. Oh, it is elect. Okay. So DFS will be DFS 3 plus like 3. No, it will be plus max sum array three plus 1 is 4 till 7. So it is 3, and this will be max sum if 3 with maximum of the group. It is 10. So 10 multiplied by length of the group is 3, it's 30. And it will have okay, so it will have so the FX3 will be, sorry, I will change it to no the FX3 will be I is 3, so it will become 4 j in range 3 minus 3 is 0, so it will be 0 to 3. Yeah, that's from here. Oh, but is it 3? Like, now for DFS3, I don't think it is. Yeah, it is like this DFS3 is correct since it is 9 pointed to 9. Yeah, because we have selected this subarray and the rest of the problem become this, and so it is DFS3 correct. And inside the maximum thing is, I think it should be, yeah, it should be DFS 0. So it should be DFS 0 with plus maximum sum with array 1, 2, 4. Yeah. It's kind of correct. And then for DFS 0, it will return array I, like 1. So I don't think, like, I'm not sure where is the issue. Okay, let's see. Yeah, this will not be run into. And for J in range, oh, it is like, oh, it is, oh, it's J starts with I. Not sure why this starts with I. Let's see. Oh, Ray J. I think it's just okay, I have to check with AI, and it said that I have lost, I did not calculate some of the combination, like if this is 0, if this is 0, then I is 0, if I is 1 and J is 0, then it will be, let's first clear this, so it would be 4, 0, and for J in range 0 to 1, and this will have df as 0 plus max sum array from J plus 1 is 1 till 2. But then, oh, so yeah, this will be like array this one and this, like DFS 0 will be this plus this. So I will separate these to 2 groups, but instead we can have this as a whole group. I didn't count it. Yeah, because when I is 0, then we'll just return. We'll not get into this for loop. So to solve this, maybe we should change this to, like, we should let I to 0 and J will be -1, so it will have -1 max array from 0. Yeah, then we can have the last element, like, no. We can have this last one, and we can also have, like if this is -1, then for the previous I is 1, then we will have 2 here, and we will consider this 2 elements as a group. So this will be -1 here, and let's see if this is correct. Oh, unexpected symbols. Okay, then we can edit the catch. Yeah, this part is definitely the first thing that I will want to optimize, because we are keep calculating the same thing as when we add another element. Like it is like a sliding window thing. Maybe not sliding window, but yeah, for each state we are just only adding one element, so we don't have to repeatedly keep adding the whole, like sum up the whole thing, or not sum up the whole thing, but check the entire array to find the maximum. It's kind of slow. Not sure what's going on. Maybe my code is slow. So let's see how we can optimize. We will not. Oh, we will not use this. Like. I don't know. Not sure. It's a little bit slow. Okay, seems it passed. Okay, so we can first use the for loop, or let's say if we will first change the DFS into for loops. So maybe we can do something here. Okay, so for a for loop, I will maintain an array to keep track of every sum, like every maximum sum of each state, and it will be max sum. No. Okay, we'll first call it maximum, then we will change the function name. So it will be 0, and it will be 0. Then we'll have n plus 1, since we want the first element to be our dummy node. So, and we will begin our for loop. Like it will be for I in range, and then we will have max sum I plus 1. Since it is a dummy node, so to store the value of the sum, we will start from I plus 1, and it will be max sum j plus just wanted to call it sum, we will have, maybe we'll just have maximum function like this. So yeah, we will have maximum function, and it will be array j plus 1 till I plus 1, and for j in range, and we can copy this. Then we will return maximum, and since we have the dumb node. Oh, I have accidentally erased an n, so I'll put it here. So yeah, and this. Oh, I think, okay, yeah, since we have a dumb node, this thing should be modified, so j will be, this will be 0, j, the smallest j should be yeah, it should, before it is I minus 1, the largest, this is I, this is I minus 1, so it is I, so the largest j will be I, so it should be I plus 1, and the smallest, I think we will have to but wait, let's have it we'll write a for loop for j, and I think it will be easier to see. So for j in range, it's still I, since j should be smaller than I, and started from, I think this should be the same. And this should be, I think it's this, you should add it by 1. I will change it to like this. let's see. Okay, this is really slow. Okay, it's passed. It even used more time. Okay, we have to optimize here. The bottleneck is here. So let's say okay, I think if we are now to take this for example, so we will first group a K, form a K group, K element group, and then keep and seeing like if K minus 1, how is the sum, and also K minus 2 if K is 3, like this. So I would if we want to maximize optimize this this function, I think we should okay, it's fine. Because I'm thinking like if we use a reversed for loop, so we can start it from here and then grow to this array and then grow to this. So we can like if the current maximum is 10, then add 5 if the current max has changed. If 5 is smaller than 10, then the max will not change, but if it's larger than 10, then the maximum change. Yeah, kind of. Yeah, we just need to maintain a maximum. So I think we can have if we want to maintain this, it is the same. Like we know we just need to first yeah, we have to first calculate the max, then we can maintain. But if we are reversed, then we have instantly, like directly, we have the first element as the maximum. So it's I think we can, yeah, like let's change. Like we will start from I minus 1 with J, then step will be negative 1, and this will be like negative 2. Let's first see if this is yeah, since we want to start it from negative 1, yeah, then this is yeah, this will be in this, like if this it's written like this, then negative 1 will be included. Let's see if it's correct. Yeah, okay, then check again. can have maximum here as gray eye, and this will be and the lens, group lens, I'll say group lens. The group max is because we have to keep track. And group lens will be different for each J loop. So this will be J, it will be I minus, it will be I plus 1 minus J plus 1. So we will have group max multiplied by group length, and group max will change if like the current added like we would like to see the current added element. So yeah, the current added element will be J plus 1 let's see, like the element, so we can have 0. And we can throw this away. Let's see. So far so good.